Hello everyone, I'm going to be talking today a bit about rational exponents and radicals. If you do not know, the word rational in mathematics is the same thing as saying a fraction. So anytime you're talking about rational, whether we're doing rational exponents, there's rational graphs, anytime you see the word rational, it is going to be talking about fractions. So you'll see on this page that when we do rational exponents, that just means we're going to have fraction exponents. And they are going to have a relationship with radicals, and radicals are the things with the square root sign. Or it can be a cube root or a fourth root or anything like that. That's what we're going to be working on. So the first thing is just converting one to the other, because as I was saying, there is going to be a connection between the two. So in this first part, it says write each expression in radical form. So if you're a person who likes formulas, what it is if you have like x to the a over b, the formula would say that this is the same thing as a radical if it was the b root of x to the a. Basically, this part right here, the x to the a, is going to stay the same, but the bottom of the fraction is going to become what's called the index, this little tiny number up here. Like, you'll have a square root, you can have a cube root, a fourth root. That number is called the index. So it's just a vocabulary word. And whatever number is in the bottom of the fraction in the exponent, that becomes the small little number there. So for example, if I have 6 to the 1/3, because the 3 is on bottom, that means it's going to be a third root. And then this part right here is just a 6 to the 1st, which, since it's a 1, you don't have to write it. So the answer would just be the cube root of 6. So that is 6 to the 1/3. If I had 8 to the 3/10, then same thing. 10 is the number in the bottom, so it's going to be the 10th root. Bottom number becomes the index. And then the other part, 8 to the 3rd, is just going to stay 8 to the 3rd. And that's all we're doing for now, converting. So if you want to pause and try the other two, you can, but it's going to be very similar. Since it's a 2, it's going to be a square root, and this says x to the 5th. Later, we're going to be simplifying this, but right now we are not. Right now, we're just kind of rewriting it. So that's it. If you have a square root, you don't have to write the 2. It's not wrong to write the 2, but most of the time you don't. So a square root is the same thing as just a 2 root. And this one, since it's a 2, it's going to be a square root of 9 to the 3rd. Which again is something we can simplify, but for these types of problems you wouldn't. I guess just as a preview of what's going to happen, I can show you what would happen, which is this is the same thing as the square root of 9, but instead of putting the 3 attached to the 9, you could put it over here instead. Those two things are the same, putting a 3 there versus there. But the square root of 9 is an actual number. The square root of 9 is 3. So you would get 3 to the 3rd power, which is the same thing as 3 times itself 3 times, right? Which is 27. So it will simplify more in future problems. But if it just says to, write each expression in another form, this is as far as you need to go. Or just write it without the 2. Okay, going backwards. If you have a radical and you want to make it into a rational exponent, then you look to see what exponent it currently has. In this case, it's just a 62 to the 1st. You have a 62 to the 1st. Then, since the index is 3, the exponent will be divided by 3. And that is the answer. 62 to the 1/3. Okay, Same thing here, it's a 23 to the first. Since there is no number here, no number means it is a square root, and a square root means a 2 root. So you'll have the 23 to the first, and since it's a square root, it'll be a 1/2. Similar here, it's an x instead of a number. It is a 5th root, so it'll be x to the 1/5, because there's no exponent right there. It's just a 1. Number 8, you need to be careful on. Keep in mind all of the other ones we've done so far has only had one thing, but this has 2. It has a 5 and an x to the 6. So first of all, you have to ask yourself, what is 5's exponent? And then you have to say, well, what is x exponent? So 5 has an exponent of 1. So when you do this part, it'd be 5 to the 1, and then over that 3. And then you have this x to the 6 over here, but it will also be put over 3, like that. That means, 1/3 doesn't simplify at all, but 6 over 3 is 2, so you can write it as x squared, x to the 2, just to simplify that. And there you go, that is rewriting radicals to exponents. Here we go with some exponent rules being thrown in the mix as well. It says to simplify, use exponent rules, and then write your answer as a radical. So we will be going from this into a radical kind of answer. So first of all, you have to remember your rules. And the rules we have used in the past for exponents are the same. Where if you have like a to the 3rd times a squared, that is a to the 5th. Versus if you have a to the 3rd squared, that would be a to the 6th. Basically, if you are multiplying things with the same base, you would add the exponents. But if you have one base with an extra exponent, you would multiply them. And then like if you had a to the 4th over a to the 3rd, then 4 minus 3 is 1, so it would just be a to the 1. So subtraction when it's a fraction, adding when it's multiplying, and exponents being exponents, multiply. So in this case, in number 9, we do have 2 y's. So since we have 2 y's, which of these 3 things do we use? And it would be this one right here. We're going to be adding the exponents. So you would have y to the 5/3, and you would be adding it to the 7/3. Add the exponents. So you have to know how to add fractions, basically, in this one. Luckily, with adding and subtracting, these ones have common denominators already. Normally, you would have to get a common denominator. But since they have a common denominator already, it's just 5 over 3 plus 7 over 3 would equal 12 over 3. The common denominator stays the same, and then 5 plus 7 is 12. But 12 over 3, that's equal to 4. So you get y to the 4th. For number 10, which exponent do you use if it's a number to a number? And that one is multiply. So it would be b to the 1/3 being multiplied by 3/5 in the exponent. So with multiplying, you do not need a common denominator. So you would just have 1 times 3 is 3, and then 3 times 5 is 15. So again, you just multiply the tops together to get 3, multiply the bottoms to get 15. But this is a fraction you can simplify. 3 over 15 simplifies because 3 goes into both of them. So if you divide them both by 3, 3 divided by 3 is 1, and 15 divided by 3 is 5. Oh boy, negative exponents. Oh boy, oh boy. That rule, if you need the reminder, is that over here in the margin. There we go. If you have a to the negative first, that's the same thing as 1 over a to the first. Or if you have a to the negative n, that's the same thing as 1 over a to the n. Basically, negative exponents become fractions. And whatever number is here, like if this is a 3, then it would be a 3 right there. If that was a 17, this would be a 17. Or if this is 1/5, then this will be 1/5. It's just a copy-paste kind of thing. It's just instead of a negative, you make it a positive. So here, x to the negative 5, 6, that's going to be 1 over x to a positive 5, 6. That changes it from negative to positive. And that's going to be our answer in exponent form. Keep in mind later on we are going to have to change these to radicals. I'm just kind of simplifying first. And then in this one, because it's division, what do you do with the exponents? Division, you would need to subtract. So you get x to the 3/4 minus 1/2. But this time they do not have a common denominator, so you cannot subtract them immediately. You need to get a common denominator. In this case, they can both be 4. If you multiply the 2 by 2, you'll get 4. So we'll multiply the top and bottom by 2. So we would get x to the 3/4 minus 1 times 2 is 2, and 2 times 2 is 4. So common denominator. 3/4 minus 2/4 equals 1/4. So that would be the answer in rational exponent form. In terms of writing things in radicals, this does not have a fraction exponent. You can't write this as a radical. You would just leave it like that. This one, b to the 1/5. 5 is the number in the bottom, so it'll be a 5th root. Since it's just a 1 on top, it'll be a b here to the 1st power, but since it's to the 1st power, you don't need it. This one is a 6th root, so the 1 will still be on top. It'll now be a 6th root. And this has x to the 5th, so we'll keep it as x to the 5th. And you know, the 5 could go under the radical or not under the radical. It does not matter. And we're going to leave it like that. So see if you can do that one real quick. It's a 4th root. And it's going to be a regular x to the 1st. But since it's to the 1st, I'm just not going to put the 1. And there you go. So now they're all in radical form. All right, this has been 13 minutes, so I'm probably going to stop it here for part 2 later. Bye-bye.